equation. Now everybody likes step 2, that you don't have to drag the units around, but steps 1 and 3 are not to be taken lightly. If you're talking about step 1, it requires you to develop a nose for what's SI units and what's not. So you scan the problem, you go, okay, meters, kilograms, what are feet? Oh, that's got to change. Grams, oh, that's got to change. Centimeters, that's got to change. So you have to make sure everything's all set before you just drop the units and throw them away, okay? Because otherwise they won't work out. And same with step 3. You need to know the units of things. Now, displacement being in meters, that's not hard. But it requires you to have an ever-expanding kind of toolkit. What are the units of force? What are the units of momentum? What are the units of energy? So you just need to know to tack them on at the end, okay? You can always work them out if you want. But I'm suggesting to you that if you get a sense of what are the SI units of things, it'll save you having to reinvent the wheel every problem. Okay, so that's a little bit of an aside on units. Are there any questions on that before I get back to the problem? Okay, and again, the units guide that I posted for you, the whole idea of that units guide is to kind of have you always have a reference for what are the units of things. What are the units that are SI? What are the other common non-SI units? All right, so I get an answer here. So let's see, the minuses cancel as well. I have 7.5 squared over 5. That is plus 11.25. It's positive. Does that make sense? Yeah, it was breaking, but it was breaking to the right. What do I answer for part A? Do I just throw in 11.25 meters into WebAssign? Yeah, exactly. So if you went 11.25 meters and then stopped, you wound up 0.75 meters from the light. Okay, so that's another little tricky thing that WebAssign will do is they'll ask you a quantity that's one little short leap from one of the 5 quantities, but not exactly. Okay. Another thing that you should be aware of, there's going to be a prominent warning note on top of homework number 2. WebAssign is going to always ask you for distances and speeds and sizes of velocities and accelerations, and always going to ask in a way that you should chop the sign. And that comes back to our earlier conversation, plus and minus is in the eye of the beholder. You can't say that the velocity is plus and someone else says it's minus, and you can't be like, you're wrong, okay? That's just how they decided to set up their problem. So WebAssign tries to treat every option the same. It won't ask you what's the velocity. It'll ask you what's the speed. So how fast are you going? Or what's the size of the acceleration? A common mistake is to put in negatives in there as if it knows what you mean by negative. It has no idea what you mean by negative, so don't put it in there. It won't ask you for that. Okay? All right, so that's the first one. Let's do the time to stop. It's very similar. We can, in fact, start with 1, 2, 3 givens. Now we're asked for the time. Let's not use the displacement. Why use it? It's nice to think we can walk up to a problem and do part B first. How interdependent these parts are is greatly exaggerated. Even if I did do part A first, maybe I did the displacement wrong and I don't want it to mess up my answer for part B now. Okay, so let's pretend that we are not using displacement simply because we don't have to. Which equation would we use? Equation number 1. Let's try it out. So this was part B. We're using equation number 1. What would that look like? Well, we're solving for t in that equation. Looks like this. Again, if your algebra is significantly slower, can't get that within about, I don't know, 10 seconds, then practice. So let's put it in. Without units, 0 minus 7.5 over minus 2.5. That is very obviously 3. And we throw on the SI unit at the end. Time is in seconds. So it takes 3 seconds to stop. Which, by the way, you shouldn't even need, because these numbers are so round, you shouldn't even need really the equations for this. You think of this, what does this mean? It means you take away 2.5 meters per second every second. So how many seconds is it going to take for 2.5 to take away 7.5? It goes in there exactly 3 times. So you can just look at the numbers, right? So after 1 second, you'll be going 5 meters per second, because you took away 2.5. Then you'll be going 2.5, and then you'll be going 0. So it'll take you 1, 2, 3 seconds. Any questions on that example before I do some more? Okay, so really nuts and boltsy stuff. I don't want to do too many examples of this. I want to move straight on to incorporating gravity. I've already alluded to the fact that gravity applies a constant acceleration. So let me just tell you the particulars of what that is. All objects, regardless of their mass or shape, are given a constant acceleration by gravity we talk about its size, talk about its direction, and we'll talk about the caveats. So there's 2 caveats to this. First, size. The size is 9.8 meters per second squared. That number is so common that we commonly call it g. Common misconception is g is the acceleration due to gravity. It's not, it's just the size. The direction is taken care of separately. The direction is downward. Downward can be notated, of course, in a number of ways. Let me give you some examples. This comes back to our discussion earlier. If you choose the plus y direction to be this way, then downward would be negative. So we would write acceleration is minus 9.8 meters per second. And notice here that the single axis we're using is switched to the y. So I'm going to write y instead of x's. There's the size. There's the direction. Separate things. You can also write this as minus g, because the minus sign is not in the g, inside the g, it is outside. It still has to be supplied. The reason why the minus is not contained inside the g is because sometimes you might want to choose the plus y to be this way. Well, then downward is now positive. Gravity still pulls down. It's just your scaffolding of what you call positive versus negative is different. And now it's really good that there's no minus inside the g, because you have no need for a minus. You shouldn't need a minus at all. Okay? So I will generally use this, but for the time being, but we will start using some really crazy choices for axes later. So I do want you to understand that there's no universal plus or minus. It's a decision that you make. Okay? Now, this is true with, there's 2 caveats. These are more for later than for right now. This is if you're near the surface of Earth, which I am going to put, that's technically 2 caveats, right? So you can't be near the surface of Mars, and you also can't be far away from the surface of Earth. Okay, so you have to be near the surface. Now, Earth is obviously the planet you're on. How near do you have to be? Well, let me give you an example. This is the Earth. The Earth has the radius of about 6 million meters. It's very big, this planet that we live on. So if you're talking about climbing a mountain peak, does anyone know roughly how many meters tall Mount Everest is? So there are 14 mountains in the world that are over 8,000 meters. So it's around that, okay? So 8,000 meters, you're about there, okay? Commercial airline flight, you're like there, okay? Bottom of Death Valley, you're like there, okay? So how far you get from the surface of the Earth in the grand scheme of things is insignificant, all right? So when we say near the surface of Earth, this is anywhere you will ever go in your lifetime unless maybe space tourism takes off and you become an astronaut, okay? This is all everyday situations. Later on, we'll start to go out into space. We gotta walk before we can fly, so all this kinematic stuff is, you know, very nuts and bolts, basic stuff. But basically, we are safe in using this value. Now, the only thing that tends to confound this idea, if I'm telling you that in this room I drop a bowling ball and a feather, you might say, what? They accelerate together? I don't believe it. I'm trying to claim that if it was gravity, up to gravity, all objects, regardless of what they are, accelerate together. So if I drop them both from rest, they should not, one should not beat the other to the ground. So what's going on? The reason why a bowling ball and a feather fall very differently has nothing to do with gravity, okay? It has to do with air resistance, okay? So air resistance is this thing that's confounding and ruins people's intuition of gravity. Gravity acts very simply, it's very egalitarian, treats everything the same. The difference is in surface area. Surely if you've ever stuck your hand out a car window while it's moving, you know that this and this cause different things. So what happens with a feather is that it tends to have a relatively large surface area for how big it is, and air resistance starts to really mess with it. Whereas the bowling ball is much more aerodynamic. If you could do that experiment in a vacuum, then they would accelerate together. It's air resistance that ruins the intuition. In fact, I'll post a video for you guys. It is on one of the Apollo missions when they were on the moon. They dropped a hammer and a feather together, and they truly accelerate together. It's obviously not at 9.8 meters per second squared, but it is still a constant acceleration that's given by that body, okay? So the thing to realize is that in everyday circumstances, we really observe gravity in concert with air resistance. We really never get a chance to observe gravity alone. And so air resistance starts to kind of mess with us and ruin our intuition about what gravity would want. But all the differences we see in how things fly or fall is due to air resistance, not due to gravity alone. So we're going to use situations where we hope that air resistance is relatively negligible, okay? So we're going to have our projectiles be baseballs and rocks and things like that. We're not going to use feathers and paper bags and things like that when air resistance could be as important or more important than gravity, okay? So that's just something we'll have to live with, because incorporating things where air resistance is significant is really hard. Air resistance is a very nasty influence to have to account for, okay? All right, so let's do it. Let's do an example. Let's see if we can knock out in the next 5 minutes just a basic example, and then we'll do more next time. This is my second constant acceleration problem. It is going to be the first one involving gravity. And here's what I have. I have a building. I'm going to drop a ball off it. It takes 2.5 seconds to land. So I should say it's dropped. It takes 2.5 seconds to land. How tall is the building? All right, so that's my question. going to put down my 5 variables in no particular order. Now we're going to put the y form of them. Let's choose a positive y-axis. I'll choose up to be positive because why not? I shouldn't be afraid of things moving in the negative direction every once in a while. What's my initial velocity? 0. What's my acceleration? Do I use this one or this one? It's minus 9.8, right? You can call it minus g, but for now let's call it minus 9.8. Now if it has an acceleration, why is the velocity 0? Well, remember, the acceleration was 0 when I was holding it, and then when I pulled my hand out, the acceleration switched to that, but the velocity still needs some time to react to that new acceleration. The time is given. Let me ask you this, is the final velocity 0?
Yes.
Well, it depends on if it bounces or not. But let me say this. If you are using this, you've made a contract with the problem, whether or not you know it. And I hope you know it, because you won't get the right answer otherwise. If you are using this, you have made the contract that gravity is the only significant influence. There can be nothing else that is touching it or influencing it in any major way, which means that this has to be after release, okay? So your hand can't be touching it anymore, because of course, if your hand is touching it, then the acceleration is 0, right? You're just holding it in place. So it has to be after the hand releases it. But that's fine, because even though the hand has released it and the acceleration has switched, it still is going to need some time to increase the velocity from there. So it has to be after release. It has to be neglecting air resistance. So as it falls, we're hoping that gravity is the most important by far, and air resistance doesn't really affect it. And most importantly, once something hits the ground, that can be a major influence, right? Gravity would like to continue it falling. It's when it hits the ground that the ground can apply a completely different acceleration. So it has to be before you hit the ground. Everything else has to get out of the way. If we're going to use the gravity acceleration, there can be no hands, there can be no ground, there can be no air, nothing else is influencing it. So this is definitely not 0. It's not 0. That would actually represent the impact speed just before it hits the ground. And the acceleration of the grounded parts is completely different and ruins the whole calculation. Okay? So this is just before the ground. Just before it hits. After that, who knows? Maybe it'll squash into the ground, maybe it'll bounce, who knows? Ground can do all sorts of things. Luckily, we don't need that to be 0 because we already have our 3 things, right? So which equation will we use? Number 2. So this tells us, by the thing that's missing, use equation number 2. So let's go ahead and write that down real quick. There's the equation. That's in the y form. Just figured I'd show you what that looked like. Let me plug in the variables. 0 equals, wait, no, that's not right. Delta y equals 0, well, times 2.5, that doesn't matter, plus 1/2 negative 9.8 times 2.5 squared. And I get a displacement of roughly 31 meters negative. Came out negative. Is that okay? Is the displacement negative? Is that allowed? It just shows that it's in the negative direction. That's fine. So if WebAssign asks how tall is a building, do I put in negative 31 meters? No, that's inferring I want an amount, a distance between the ends. Again, don't try to put your arbitrary sign choices into the fields in WebAssign, okay? So someone else could have done the problem with the downward direction being positive, and they would have gotten a positive displacement, same amount, 31 meters, but in what they call the positive direction. So make sure you strip that sign. Okay, so I think let's leave it there. I'll do another example next time.